All right, so let's take a look at a couple questions here. So first, it says, write the equation of the parabola. So what equation represents the parabola? With focus at 5, 5, and directrix, y equals 1. So if we take a look here, right, they've done all the graphing for us, right? We've graphed the vertex, we've graphed the focus, and we've graphed the directrix. So yes, they identified the p-value. Your p-value is 2 because that's your distance between the focus and the vertex. And your vertex is 5, 3, and that's your h and k, right? So our formula is y minus k equals 1 over 4p x minus h squared. We just got to plug in our numbers, right? So we know p is 2, and then the 5 and 3 are your h and k. So y minus 3 equals 1 over 4 times 2 times x minus 5 squared. Right? And this is y minus 3 equals 1/8 x minus 5 squared. If you want to, you can bring the 3 over by adding it. It just goes at the end. And this would be your vertex form. Y equals 1/8 x minus 5 squared plus 3. Right? Again, if you think about your parabolas, right, this is a translation to the right 5 and up 3. So from the origin, right 5, up 3, there's your vertex. And because of this 1/8, you're actually kind of wide. Okay, remember from your knowledge from Algebra 1, if your a value, and we think the absolute value of a, right? If it's less than 1, between 0 and 1, then you're going to be a wider graph. So I know that the point 4. So 4 to the right and 2 up is on this graph. So this will be on the graph right there, and then other side 2. And again, I just know the shape of what it's going to look like, right? We're going up, you're actually going up 1/8 as high, right? So 4 squared is 16, an eighth of 16 is 2, so 4, 2. Again, that's just my knowledge of parabolas, but there you go. So that's what the picture would look like. All right, next. Okay, it says graph the parabola with a focus at 5, 5, directors y equals 1, with the equation y equals 1/8 x minus 5 squared plus 3. So again, going back to my Algebra 1 days, so I'm going to draw a couple different graphs here. First, the generic y equals x squared, right? So here's 0, 0. 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4, right? So there is your, right? We call this the parent function. Okay? So now I'm going to change colors, and in blue, I'm going to graph y equals 1/8 x squared, right? So if the vertex is not going to move, so it's still 0, 0. But if I plug in 1, I get 1/8, right? Because 1 squared is 1. So that's not very high. And again, this is that same graph we had graphed before. Okay, this problem was us going backwards. So I know that if I plug in 4, 4 squared is 16. 1/8 of 16 is 2. So I'm going to do 1 and 1/8. So 0, 0, 1 and 1/8, and then 4, 2. I'll do the same thing on the left-hand side, right? There is symmetry about these parabolas. So 1, 2, 3, 4, 1, 2. And now here's that one. And again, I'll try to do it dotted. Okay, so now if we take a look at these, the h and k, right? So the h here is a -5. The k here is a 3. So this is your h. We're doing purple. This is your h, that's your k. When you pull out the h, though, you always go opposite of what it says. So that's a +5, and then the k is +3 here. If it was of this form, y minus 3 equals 1/8 x minus 5 squared, you would take the opposite of both. So this would be your k, this would be your h, but your vertex would still be at 5, 3. Right? So again, be careful with that over there. Okay? So now I'm going to take this and go to the right 5. 1, 2, 3, 4, 5, and up 3. 1, 2, 3. And now I'm going to take the points. So this point right here and go 1, 2, 3, 4, 5. 1, 2, 3. And take the point 4, 2 and go 1, 2, 3, 4, 5. 1, 2. So there's the right-hand side of my answer, right? And then, again, Around the vertex, there's symmetry, right? So we're going to take this axis of symmetry, again, if you remember from Algebra 1, and we're just going to reflect. So this point goes here, and this 4, 2, I'm sorry, this should be 4, 2. I apologize. To the right 4, up 2. That's why it's a little bit flatter than I thought. Sorry about that. So from here, go 1, 2, 3, 4, 1, 2, up here. So there we go. So that's a better curve, right? So there's that, and then go 4 this way. 1, 2, 3, 4. There we go. And again, I'll do my best. And there you go. So this would be the parabola that matches this graph right here. Again, if I take, let's take green, or let's take orange. And if I plot the focus and the directrix, so the focus at 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 3, 1, 2, 3, 4, 5. So there's your focus. And then your directrix is y equals 1. So go to where y is 1, and then draw, they use a solid line, so I'll do the same thing, draw a solid line. And there you go, that's the line y equals 1. And again, if we use this point right here, right, if we go down 4 and we go left 4, that point is equidistant, right? This distance is the same as that distance. So any other point I use, so let's do green. Say I choose this point right here, right? So this vertical distance to the directrix should be the same as this diagonal distance to the focus, right? So distance 1 should always equal distance 2. D1 should equal D2. Okay, so there's a quick little recall of graphing, right? And the other thing too is if you had defined, say you had defined, I'm just doing a couple different type of questions. Say you had defined the p-value, right? So that 1/8 equals 1 over 4p. So that means 4p equals 8 divided by 4. Your p-value equals 2. So that should be the distance between your vertex and your focus, and your vertex and the directrix, which is 2, right? So I do have that. Okay. So again, if I had the vertex, I could find the equation of the focus, or the point of the focus, and the equation of directrix just by being given the formula. So keep that in mind, right? A lot of moving parts in this stuff. Okay, and let's do one more question here. So here's the real application part of this. So it says the cross section of a satellite dish is a parabola. All right, so here's this word parabola with the feed horn at the focus. So this feed horn right here is at the focus. So right there. That's our focus. How long do the braces holding the feed horn need to be? So these are the braces right here. Call that lowercase b. Right? We need to figure out what that length has to be. Okay. Now in this picture, you see that from again, this is a cross section of a parabola, right? We're doing 2D of a 3D. So this right here, this distance is 60. That's the distance from the vertex to the horn, right? 60. But then you have the mount up here 10 more away. So this distance is actually 70 from here to the vertex. All right, so keep that in mind. So that's what this picture right here represents, right? So you have 0, 0 is your vertex. You have the focus at 0, 60, and then the brace ending at 10 more above that, so at 0, 70, right? We picked this point here. We know that the width of this satellite is 150, so that this and this will be congruent, so half of that 75 and 75. So we know we're going to the right 75. We just don't know how far up from the vertex we had to go. So we don't know this h value. But if we could find this h value, this is just a right triangle problem, right? If I use blue here, this is the right triangle we're going to focus on, right? I know that that's 75. Now once I find h, I can take 70 and subtract h. So that length is going to be 70 minus h. And then I can use that to find my length b for my brace, right? My question mark. Okay, so first things first, we're going to come up with the equation of this parabola. All right? So step 1, the equation. We know that the vertex is at 0, 0, so this is going to be 1 over 4p x squared. Our p value is the distance from the vertex to the focus. So that's going to be our 60 centimeters. That's our P. So P is 60. So our equation is y equals 1 over 4 times 60 x squared, which means that's that's y equals 1 over 240x squared. Right? There's our equation. Okay. Step 2, and again, I'm trying to do as much as I can on this page. Step 2, now we're going to find this h value. We know that x is 75. What is our y value? So I'm going to plug in h for y. So h equals 1 over 240 times 75 squared. Okay? And I'll just plug this in and I'll round. When I get an answer, I round it to 23.4. It was 23.43. I rounded 23.4. That's our h value. So to find this missing side of this right triangle, we're going to do 70 minus 23.4. And that is 46.6. What is it in centimeters? Okay, so now I think I'm going to go to the next page and just draw the right triangle that we need to use. Or actually, I'm going to clear it. I'm going to clear this here and do it right here. Okay. Okay, so right now we know that this distance is 75. We found this distance to be 46.6, and we're looking for that distance, right? So we can use Pythagorean theorem. So this is step 3. A squared plus B squared equals C squared. Let's let 75 be A, 46.6 be B, and our brace length be C. And we'll just call it C, right? So 75 squared plus 46.6 squared equals C squared. We're going to take this and type it in all at once and round to the nearest tenth. When you do that, you get 88.29. So when I take the square root of both sides, my C value is 88.3, and that would be in centimeters. And that's how long the braces have to be to support this feed horn. Okay, so there's your application of these parabolas. All right, so thanks for watching. Best of luck in the practice assignment.